Chapter 6, Lesson 2, Advanced Algebra, and I want to walk you through one very common problem that you'll need to do, which is an application of the cubic function, and that's the volume of a rectangular object. Now, you'll just need to memorize this formula, but the volume of a rectangular object is the length of the object, and multiplied by the width of the object, and then multiplied by the height, and that will give us the volume of any object. Now, in most cases, what they'll do in a problem like this is they'll talk about the relationship between these dimensions. They won't give you any one. They'll usually talk about the relationship between two, and then they'll give you either the area of the bottom of the rectangular surface of the bottom or the perimeter, and then so you'll need to know how to figure out the area of a rectangle, length times width, or the perimeter, adding the lengths together in order to determine the last one. So let's walk you through a problem, and hopefully that can serve as a reference for you as you move forward. So it talks about popular models of carry-on luggage, and it says here that they have a length that is 10 inches greater than their depth. Now, whenever you see a comparison like that, we always take the second thing that they talk about, and we're going to make that x. So we're going to make the depth x, because once I know what the depth is, even if it's a variable, I know that the length is 10 inches more than that. So it's very simple to write the length as 10 inches more than the depth. So that gives me those two values. Now, in order to figure out the volume, however, I need to know this depth, this height dimension as well. And I don't know what it is, so I need to give it a different variable because I've already used x for the depth. So now if I wanted to use volume, I have x plus 10 times x times y. Now the problem with that is you have two variables, and you don't want to have two variables because then you can't solve for one. So we need to have some other way to figure out what this y is. And they always then, like I said, tell us something about the area or the perimeter. And it says here that the sum of the length, width, and height, depth, must not be more than 40. So if I were to take these three dimensions, x plus 10, and add that to the x and add that to the y, the sum has to be less than, or let's say in this case equal to 40. That's as big as they can be. Well, now that I have this equation, I can solve this for y, move everything to the other side, and that will give me what y is in terms of x, and then I'll have x for all of my dimensions. And again, they'll always do that with either perimeter or area, allowing you to figure out what that last dimension is in terms of x. So solving this equation for y, well, let's see, if I added these two x's together, that's 2x, and then move it to the other side, that's going to be negative 2x. And then if I subtract 10 over here, this is going to be plus 30. So this dimension is going to be then negative 2x plus 30. Well, now that I know what those dimensions are, I can figure out what the volume is. Okay, the volume, remember, is the length times the width times the height. So the volume is this length times this width times this height. So it's going to be x times x plus 10 times negative 2x plus 30. And that's going to give me the volume. So now what we can do is make a quick sketch of that by figuring out what the zeros are. Well, the 0, what makes this one 0 would be 0. What makes this one 0? A negative 10. So out here at negative 10. And what makes this one 0? Now this is a little bit harder to determine, but again, if you just think about what you want, I want negative 2x plus 30 to equal 0. I want to make this 0. So you just set up a little equation to solve that. So negative 2x is equal to negative 30, so x would be equal to 15, so way out here at 15 is my other 0. Now this is a cubic, so I know it's going to look something, actually it's a negative cubic, because this is a negative sign in front, so that means it's going to be reversed and look something like this. Okay. Now before we take a look at the graph and look at the answers, let's think about what we have here, because we're going to have these on an x and y axis. So what does x represent and what does y represent? Well, x is part of the dimension. So the x values that I have along here are the actual lengths in inches of any of that are possible. So this x-axis represents the length in inches of any value. The y value, the represents what then? Well, what's in the place of the y? The v. So these y values are different volumes that you get when you use these different dimensions. So if I use a dimension of 0, what's my volume? Well, 0. If I don't have any dimensions, I'm going to have 0. Now, does it make any sense to use negative lengths? Well, no. So these values really aren't even going to be used in this case because we're only talking about positive values when we're talking about actual lengths of an item. Now also, if the y values are the volume, it doesn't make any sense for me to talk about these over here because these are negative volumes. And again, you can't have a negative volume that makes any sense. So really, the only values we're looking at are the dimensions between 0 and 15 that create these different volumes for us. Now you'll notice that this is an upside down parabola, this section of it, and this creates a maximum point right here. So at this point here, we get the maximum volume if the dimensions correspond to this x value, whatever it is. So we're going to be very interested in these x values. And that's why these cubic functions are so applicable to something like this, because we can figure out what dimensions we need to make our object in order to give us the maximum volume. Okay, so that's pretty much going to walk you through the rest of this problem then. When it says here to describe a realistic domain, that's what we just talked about. What numbers make sense in the context of what we're talking about? Negative dimensions don't make any sense, so we can ignore the negative x value. And negative volumes don't make sense, so we can ignore the negative volumes. So we're really only going to be looking right in between these two zeros here, this 0 at 0, 0, and this 0 at 15, 0. All right. And then what's the maximum volume possible? We would then use our calculator and calculate that maximum just like we did with the cubics. And so that would give us a maximum volume of 2,052 cubic inches. That would be the y value. We would look at the y value, that's the volume. And then the x value that gives us that is about 8.9 inches. So 8.9 is my x. So then I would go back here. So 8.9 would be this value. Then I would do 8.9 plus 10 to get my length because it's 10 inches more. And then I would do 2 times 8.9 negative plus 30 to get the dimension for my height. And that would give me the dimensions that would give me the maximum volume, and at the same time keeping it at 40 inches as a maximum perimeter. All right, again, I hope that helps, and you may need to watch this over a few times if you need, but you can use this to kind of guide you through these types of problems. But it's a very common type of problem, something you need to get very good at. So anytime you have a chance to do a problem like this, it would be a very good idea to take that opportunity to walk you to do it and to really get to understand it. Okay, so that'll wrap up this lesson, and we'll move on with the next video.